Welcome to True Projects. In this video, we are going to explain about a project titled Malware Detection using Machine Learning and Performance Evaluation. The primary objective of this project is to address the vital challenge of detecting the malware through the application of machine learning algorithm. Given the risk, frequency and complexity of malware attacks, it is imperative to develop the reliable approach for identifying and categorizing the malicious software. The project specifically focuses on employing the diverse machine learning algorithm including SVM, KNN and ANN to accurately predict and classify more than 20 distinct types of malware attacks. By leveraging an extensive data set and implementing an advanced techniques like feature selection and optimization. The main goal of this project is to create and assess the machine learning algorithms such as SVM, KNN and ANN to achieve the efficient malware detection. By utilizing a varied data set of different types of malware attacks, the objective is to accurately predict and classify the malware signatures. The project incorporates feature selection through PSO optimization and evaluate the performance of the algorithm using the metrics like accuracy, precision, recall and F-measure. These are the basic requirements that are needed to build this project. Hardware requirements: operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDEL with version of 3.7. These are the modules that are developed to implement this project. The first module is Upload Dataset. In this module, the malware dataset is uploaded to the application. This dataset likely contains samples of different types of malware and it will be used for training and testing the machine learning model. And the second module is Pre-processing or Data Exploratory Method. This module involves reading the binary values from the dataset and converting them into grayscale images. This transformation allows for the visual representation of the malware samples. And the third module is Feature Selection or Optimization. To improve the prediction accuracy and reduce the number of features, the module applies a particle swarm optimization feature selection algorithm. PSO algorithm helps select the most relevant feature from the available set of features in each image. By reducing the feature space, the algorithm can focus on most informative characteristic of malware sample. And the fourth module is Run SVM algorithm. In this module, the data set is split into training and testing and part. The module builds a support vector mission. By using the training data, the trained SVM model is then applied to the test data to calculate and evaluate the prediction accuracy of the model. And the fifth module is Run KNN algorithm. Similar to the SVM model, this module also splits the dataset into training and testing and build a k-nearest neighbor trained model using the training data. And the KNN model is then applied to the test data to calculate and assess the prediction accuracy. And the sixth module is Run ANN algorithm. And this here ANN trained model is constructed using the training data and the ANN model is used to predict and evaluate the accuracy by using the tested data. And the seventh module is Comparison Graph. And this module generates the various metric graph such as accuracy, precision, recall and F-measure to evaluate the performance of all the algorithms used. This graph provides a visual representation of how each algorithm performs in terms of different evaluation metrics. And the eighth module is, and the final module is Predict Malware from New File. In this module, a new malware file is uploaded to the application. The file is converted into a grayscale image and then the PSO algorithm is applied to the extract relevant features. Finally, the machine learning algorithm is employed to predict whether the uploaded file contains the malware signature or not, providing a real-time assessment of the file's maliciousness. The execution of this project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files, and the dataset folder consisting of the malware files, and the image folder consisting of the images for the malware file, and these both are JPG files, and the bad and malware detection, these two files are the Python code files. And the report test file is used to give the optimized information about the malware files, and the run is a bad file. Instead of executing the program in command line interface, we created the Windows bad file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Malware Dataset button. By this button, we are going to import the dataset from this corresponding folder and selecting the one folder from it. And here the malware dataset is loaded, where the total malware dataset records are found of 350, and total malware features found in each record is of 1024. And here the dataset is divided into the training and testing part, where the training dataset is of size 280 and of testing dataset of size 70. And then click on malware family graph. Here, this graph represents of malware family. Here, x-axis represents of the malwares of types, and the y-axis represents the count of each malware. And then close this graph and click on Run SVM Algorithm button. Here, the SVM algorithm gives an accuracy of 61.6 and the precision of 61.64 and recall of 61.4. And here the confusion matrix, and the x-axis represents of the attack name, and the y-axis represents of the numeric value, and that contains the count of the prediction. And then close this matrix and click on Run KNN Algorithm button. Here the KNN algorithm is generated and gives an accuracy of 62.8 and recall of 62.8 and the precision of 62.8. Here, this is the confusion matrix, where the x-axis represents the name of the attack and y-axis represents the numeric value of that attack. And then close this matrix and click on Run ANN Algorithm with BAT. Here, this is the confusion matrix that was formed by using the ANN algorithm BAT. It gives x-axis represents of the epochs and the y-axis of name and the count, and then close this matrix, and it gives an accuracy of 64.2, recall of 81.8, precision of 65.9. And then click on Run ANN Algorithm with PSO. And here, in the same way, it gives an confusion matrix as like of ANN with BAT, SVM and KNN. And then close this graph. ANN with PCO gives an accuracy of 100, as of recall 100, as of accuracy 200. And then click on accuracy graph. Here, the x-axis represents the algorithms we used in this project, and the y-axis represents of the value assigned to the each algorithm. And close this graph and click on precision graph button. Here, this graph shows of x-axis represents the algorithm name and the y-axis represents the precision of the each algorithm we used and click on recall graph button. Here this is the bar graph where x-axis represents of the algorithms we used in this project and the y-axis represents the value of the each algorithm of recall, and then close this graph and then click on malware predict from new file and select one folder and click on open button. Here the uploaded file contains the malicious code from family dialer adduler, and then close this graph and the uploaded file contains the malicious code from family of this. In this way we can detect the malware by using the machine learning algorithms. In this project, we addressed the important task of malware detection using the machine learning algorithm by utilizing a diverse dataset containing of different malware attacks. We employed SPM-KNN ANN algorithm for prediction, and the dataset was preprocessed by converting the binary signature into gray color images, and relevant features were selected using the PSO optimization. The performance of algorithms were evaluated using the metrics such as accuracy, precision, recall, and F-measure, and the ANN with PSO optimization gives an accurate and more accuracy when compared to that of the other models. Thank you for watching.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.